chart, you got R, W, R plus W, R minus W. We're going to fill that out. That is going to be something they're going to be using throughout this worksheet in this section. And let's think about what they are. First of all, if you have, if you're traveling somewhere, you may be going, 400 miles an hour on an airplane, and the wind is blowing on the airplane. You're going with the wind. So for example, I'm going 400 miles an hour, and wind is going 50 miles an hour, right? It's kind of helping you go towards that way. How fast am I traveling? If my plane is going 400, and the wind is behind you, 50 miles per hour, how fast am I going? Yeah. 450 miles an hour, right? And my eyes. Anyway, 450 miles an hour, right? So, but what if you're going against it? Are you going any faster? If you're going 400 miles an hour and then the wind is now you're against going 50 miles an hour, how fast are you going? Yeah. 350 miles an hour. Is that right, guys? That's your actual traveling speed, right? Does that make sense? So that's the kind of question that we're going to be doing tonight. Okay. So as you can see, guess what the R stands for? Rate of what? Rate of the jet. Okay. So write that down. They forgot to put let. So write let R be the rate of the jet. Or does it have to be jet all the time? It could also be boat. Yeah. So as you can see, it's going to involve wind and water, so it could be jet ski. Okay, fine. So whichever. So write down. R is going to be the rate of. So let canoe. Okay, fine. Let R be the rate of the moving object. Okay, fine. Okay, rate of the jet, airplane. Airplane. Fine. Okay, jet's fine. Airplane. Let me erase that. Boat. Okay. Also, let. Guess what the W stands for? Shh. Okay, here we go. Guess what the W stands for? Wind. What about the wind? The rate. Rate of the wind. Does it always have to do wind? What if I'm on a boat or something? It'll be rate of the water or the current, okay? Okay, now let's see if you really. Then what does R plus W stands for? Okay, raise your hand. Raise your hand. Pecco?
If the wind or the water is traveling with you.
Yeah, if they're behind you, if they're pushing on you, right? If they're helping you. So this is the rate of the. Let's just do a jet plus the what? Rate of the wind, right? So of course you're traveling faster, correct? So if you're going 400 miles an hour, right, without any wind or anything like that, but if it's helping you, 50 miles an hour, the wind is 50 miles an hour, you're going 450. Does that make sense? What about this? R minus W. What does this represent? Yeah.
Rate of jet minus
Rate of the
jet.
good jet minus rate of the wind or something like that. I mean, it doesn't have to be jet. It could be boat, right? Depends on where you are. And so is this going to be slower or faster? Slower, because let's say you're going on a jet for 400 miles an hour and then the wind is blowing against you, like 50, then you're really going 350 miles an hour. Does that make sense? Well, that's the kind of thing that we'll be doing throughout this whole section. Does that make sense? Okay, so anybody need more time? May I then, let's read number 1. Okay, who wants to read for us the example 1? Okay, how about 3? Okay, go ahead, Danielle, go ahead.
A jet can
4
travel
people.
the 6,800 kilometer distance between New York and Paris in 6 hours and 48 minutes with the wind. The return trip against the same wind takes 8 hours. Find the rate of the jet in still air and the rate of the wind.
Okay, so basically, what's going on? Can somebody explain this situation? What is it going on here? What's going on? Tina?
So a jet is traveling a 6,800 kilometer distance
Yep.
from New York to Paris, I think,
Uh-huh.
in 6 hours and 48 minutes. But then when they're coming back, the wind is pushing on them. So when they're going the opposite direction of the wind, it took them longer. So it took them 8
That's right. It takes longer, right? Why does it take longer? To go from New York to Paris, it's only 6 hours and 48 minutes. Why does it take longer to come back? Yeah, Kevin? Yeah, wind resistance. It's blowing against you. The wind is against you, so it's going slower. Does that make sense? So what are the unknowns that we have? Yes, Barry?
The rate of the wind and the rate of the jet in still air.
That's right. The rate of the wind, that's unknown, and rate of the jet in still air. What do they mean by still air? Yeah, Scott?
The rate of the jet without any.
Yeah, without any wind like blowing against it or, behind it. Yeah.
If they were asking for how long it would take the trip in still air, couldn't you just find the middle number between 6 hours 48
Oh.
and 8 hours? If they're asking
Yeah. Yeah, so if you're looking for the average and so forth, okay. But that's not what they're asking, I think. Yeah. Okay. So we declare our variables like this, okay? So go ahead and write it down. Now, I said R be the rate of the jet in still air, and W be the rate of the wind, and rate of the wind, okay? So, by the way, when you have like rate, time, and distance, do you know any sort of relationship of rate, time, and distance? What's always true if you have rate, time, and distance? Do you know? Yeah, rate times time equals distance, and whenever you have rate, time, and distance, rate times time is always going to give you the distance, right? Yeah, so do you think I could do a little table for this? It's not that bad though, isn't it? So whenever you have R, rate, time, and distance, make a little table, okay? It'll make it a lot easier. Okay. So, okay, so there are two situations, right? The plane is going with the wind, right? Another scenario is the plane is going against the wind. And I wrote down R times T equals the distance. Right, we do a little table. Now, who can tell me the rate with the wind for this plane? One person? Two? I'm sure there are a lot more. Anybody else? Yes? 6 hours and 48 minutes is not the rate. That is the time, right? So what will be the rate for this plane? 6,800 kilometers is the distance. So look what we don't know. We don't know the rate of the plane or the R. Is it R? With the wind? R plus W. Okay. Now, Amber, what do you think against the wind will be then? The rate up against the wind. If the rate with the wind is R plus W, R minus W is exactly what it is. Okay. So you will put that in. Because we have our two variables, right? The rate of the jet in still air and the rate of the wind, right? So you would use R plus W for the rate with the wind and R minus W for the against the wind. Do you all understand what I'm saying? Okay. Now, what about the time? Do we know the time it takes? Okay, raise your hand. For you to go with the wind, what did they say here? Yes, Sasha? 6.8. How did you get 6.8?
Because 48 minutes on 60 is 4/5.
Very good. So could I use 6.48 as the hour? No, we cannot. That's not okay. So what I did was I wrote down 6 and 48 over what? 60, not hundreds. There are 60 minutes in 1 hour. Yeah, Stephanie?
6 hours.
Oh, could we change it to minute? I wouldn't do that. Why not? Yeah.
Because it makes it like bigger numbers.
Yeah, you're gonna have really big number, the rate. And usually the rate of plane and things like that is per hour, not per minute. So that's what I did. Question?
On the table, can we just write like 6 hours 48 minutes?
No, I wouldn't do that because you're gonna make a mistake if you do that. So look what I did here. I did 6 and 48 over 60, which is, just like Sasha said, that's 6.8, but I like fractions, so I left it as, I simplified the fraction. Isn't that same as 6 and 4 over 5th?
What if you like decimals?
If you like decimals, you could do it. But you will find out that in a minute, that if you do with decimals, it's not going to work out too well. Okay, so, and of course, the distance is going to be the rate times time. So I wrote down, and notice what I did with the rate. I made it into an improper fraction, right? 6 times 5 is 30. 30 plus 4 is 34, correct? So 34 over 5. Now, what about the time that we're going against?